I decided to take the forced fines migration experiment to another level and take a look at chalk again. And chalk was the original experiment that I started with that really said to me that fines didn't migrate as much as we thought they did. So I started out with some spent coffee and I put a layer of chalk in the middle this time instead of the top and bottom, or I just put it at the top before. But my expectation is that the fines in the top and the bottom are going to come out more and they're going to move around more because of the water agitation, which is what happened in the previous experiment. And I'm wondering how much of the chalk will come out into the cup. Because that, as part of the original question when I published the experiment, was how similar chalk fines were to coffee fines. And I said I wasn't certain, but I didn't see any in the cup, and it was really hard to tell. So I prepared the puck, and we shall get some chalk in there. So I used just a regular knife, and I scraped off chalk into a plate. This happens to be a little not as off-white. It's not white, but it's like purplish. So I was just looking for a chalk color that gave contrast, and that one was easily available. So it comes off extremely fine. So much finer than coffee. There's not many big chunks in there. And that's just with a knife. So chalk in general is pretty brittle. So then I just added this to the middle and I tried to get a good distribution so it was kind of spread out. And then I added some grounds on top and it came out to be about 15 grams total. So let's start the experiment. I added some room temperature water again, and I start pulsing. So this, as you can see, pulls up a bunch of fines into the top, and they're also coming out of the bottom. And there is some off color, some white in there, which I think is the chalk, but it's kind of hard to tell. Even in the particles up at the top, you can see there's some wider particles. There's more, it's a little difficult to see, but they're there. And I can redo this clip and show the white particles a bit easier. So we'll take a slow motion view of the top section, which I think shows pretty well what's going on. And so you see the finer particles coming out, the finer coffee particles. And then it's a little bit easier to see the kind of white bits, which I think are chalk. So these start to appear. Which means that the finer chalk is getting moved around in the same way as fines are getting moved around, that they're not getting stuck in coffee in some weird way. So this helps speak to the idea that using chalk to emulate fines is a pretty decent experiment. And then we'll go back to finishing the rest of the shot just for completion's sake. So we'll unscrew the top so I can separate the plunger in the top, then add some more water, and then we'll do another round of water just to see what we get out of it. Because usually you still get quite a bit of fines moving out of it. And so here we go. This time we will focus on the bottom half to see what's coming out into the cup. So again, this agitation really moves around on all the fine particles, which allows them to flow through the puck and really migrate. You know, this is a level of migration that's not seen in coffee, otherwise cups would be very muddy. And you're ending up with like a 1/4 gram of coffee grounds, which is quite a bit, versus a normal shot, which has less than 0.01 grams of grounds in it. And we see a lot of white particles in here and some foam, which can be attributed to the chalk. So let's take a look at the puck afterwards. See what we see. It's a little trying to get out. It's trying to be as gentle as possible. And then, so there's not a clear indication that there's like a bunch of white spots on there. And there's not a clear indication from the sides of any particular movement. But as we cut the puck open, this, what was a flat line, is very uneven. It's very crooked of where the white chalk is. There's still quite a bit of chalk in there. It's not that most of the chalk migrated either, which is a little surprising. You could see it. So I took a few more views of this to try to get some clarity on what kind of movement was going on. And I didn't see finer coffee below, which is probably because the coffee got loosened up in the liquid and so just went all the way through and out of the puck when it was completed. I spread out the spent coffee on this black top before I put on some liquid coffee, and it was hard to see if there was any chalk there. It might be because it was so small, but I wouldn't say that I found any chalk in these leftovers that came through. But this is all the coffee that came through the puck. So quite a bit will come through this way using this agitation, but not with a normal shot. I also looked at the liquid that came out, and I left it in a cup, and there's stains up the side of white, which I think are chalk. The coffee doesn't stain like that. So I also took some coffee samples and I dried them out on top of my Crew Sifter because it was flat, it was black. So there's a bit of chalk I put up there for like in a little bit of water up at the top, that white part, to kind of show what the chalk looks like dried. And it doesn't look like how coffee dries because there's quite a large stain, and that's not how coffee dries. This is definitely from the chalk and bits of coffee that were still in this solution. And then I had like a bunch of fines left over, and again it was about 1/4 gram that came out of solution, like in my previous experiment. So I think this goes to show that chalk is pretty good in terms of helping determine how much fines migrate, and we were able to visually see it when they did in fact migrate. But previous data has shown that during normal puck conditions this is not occurring. This is only because we are forcing fines migration.